Hello, in this video we are going to see a fairly long example of a 3x3 linear system of equations. The system that we are considering has a parameter m, which is a real number different from 0, and the parameter shows up, as you can see, on the first equation and also on the second equation. We want, first of all, to use row operations to reduce the system to row echelon form. And then after that, we are going to be discussing for the values of the parameter m when the system has no solutions, when it has infinitely many solutions, and when it has a unique solution. And in the cases where we have solutions, we also want to find them. Now, the longest part is going to be the row echelon form. So let's get started with that. We are going to write the matrix as an the system, as an augmented matrix. So only writing the coefficients. So for the first row, we have 1, 4, m, and then on the other side of the line, minus m. For the second row, we have m plus 1, 4, 1, and 1. And for the last one, 4, 4, 1, 1. And the first thing that I'm going to do is to switch the first and the third row. So I'm interchanging the first and the third row, and that's because I want to use the first row, the one without the parameter, to do the operations to make the zeros for the row echelon form. So 4, 4, 1, 1, and then I leave the second as it was, and the new third row is 1, 4, m minus m. And my first goal is going to be to get for the first entry of the second row a 0, and for the first entry of the third row a 0. To achieve this, I'm going to multiply the first row by m plus 1, so m plus 1 multiplied by row 1, and then I'm gonna subtract from that 4 times the second row. So I'm gonna have 4 times m plus 1 minus 4 times m plus 1. So I'll write here again the first row as it is, 4, 4, 1, 1, leaving a little bit more space because we're gonna need it. And then for the second row, the first entry, I made it 0. And now I'm going to be careful to write down what I have to write in the rest of the entries, because it can be a little bit confusing. So this is just auxiliary notes for myself. I'm going to have 4 multiplied by m plus 1, that's the entry from the first row, minus 4 multiplied by 4, that's the entry from the all second row. So I'm going to have 4m plus 4 minus 16. So for the next entry, I will write 4m minus 12. For the next entry, I'm going to have m plus 1 multiplied by 1, so m plus 1, and then minus 4 multiplied by 1, so minus 4. So the third entry of the second row is m minus 3. And the last entry is also going to be m minus 3 because it's the same coefficients we are multiplying for the first row and for the second row. So this is our new second row. I could write a new matrix for the next operation, but I can also write it here because it's going to be an operation that only affects the third row. I'm going to multiply the third row by negative 4, and I'm going to do the first row minus that to get 4 minus 4 is 0 on the first entry of the third row. And then I'm going to have 4 minus 16 for the next entry, so negative 12. And then I'm going to have 1 minus 4m, and then I have 1 plus 4m for the last entry. I don't need these notes over here, just delete. So this is my new matrix, and now I need to achieve a 0 on the second entry of the third row. That's going to be a little bit complicated. I'm going to do it in 2 steps. On the first step, I'm actually going to make the expression to depend on m and not on the constant by doing, I'll write it here, I'm going to write R2 minus R3 for the third row. When I do that, I'm going to have 4m minus 12 plus 12. So that will give me an entry that it's a little bit simpler for m. You will see why this is better in a second. Let me just first write that everything else, the first row, 4, 4, 1, 1, stays the same. And the second row as well, 0, 4m minus 12, m minus 3, m minus 3. The 0 stays the same because I'm operating with 0 minus 0, that's fine. Then for the next entry, I'm going to have m minus 3 from the second row minus 1 minus 4, m from the third row. So that's going to be m plus 4m and minus 3 minus 1. So that's 5m minus 5. Minus 4, sorry. And for the last entry, I have m minus 3 minus 1 plus 4m. Doesn't fit very well here, but this is giving me m minus 4m, so minus 3m minus 4. I made a tiny bit more space here for the next operation, and it's okay if you still think like, what am I doing? Does this make any sense? You will see that it does. So what I'm going to do over here is I'm going to substitute the second row by the second row minus the third one. So by doing that, I'm going to eliminate from the second row the 4m, and you'll see that this actually is useful. So let me write again the entries that stay the same: 4, 4, 1, 4, 4, 1, 1 for the first row. We are not changing the third one, so I'll write it as well: 0, 4m, 5m minus 4, minus 3m minus 4. And now I need to do, well, the first entry is going to be 0 anyways, it becomes 0 minus 0. And then I'm going to have, I'll write with a different color over here, 4m minus 12 minus 4m for the second row. So the 4m's cancel, and I'm left with minus 12 for the next entry. And then I need to write m minus 3, that's the third entry of the second row, minus the third entry of the third row, so 5m minus 4. This becomes m minus 5m, so we have minus 4m, and then minus 3 plus 4, so plus 1, so minus 4m plus 1. For the last entry, we have the m minus 3 minus the last entry of the last row, so minus 3m minus 4. And this is for the m's, we have m plus 3m, so 4m. And for the constant, we have minus 3 plus 4, so plus 1, so 4m plus 1 for the last entry. Okay, so I did 2 steps. They look kind of complicated, and it also looks like I didn't make any progress because I still have the 2 zeros we had before and nothing else. But actually this did help us because now it's going to be much easier to eliminate the second entries here in the third row. We are going to multiply the negative 12 by m and the 4m by 3, and then when we sum, we get the 0 that we want. So that was our trick. We just need a little bit more space for that. So I'll keep the first row as it is, 4, 4, 1, 1. I'll keep the second one as it is, 0, negative 12, minus 4m plus 1, 4m plus 1. And then for the third row, I'm going to write the second row multiplied by m, so m are 2 plus 3 times the third row. So 0 times something plus 0, 0 anyways, but I'm going to have over here minus 12m plus 12m for the next entry. So we got the 0 we wanted. And then we are going to have, and now this gets interesting because we're going to have terms with m squared. We are going to have m multiplied by negative 4m plus 1, and then plus 3 times 5m minus 4. I need to write this down. I can't just do it on my head. So we're going to have minus 4m squared, and then plus m plus 15m minus 12. So this is our new entry. We have to squeeze it a little bit over here. Actually, let me write it one more time here. Minus 4m squared plus 16m, and then minus 12. I'll take 4 as common factor when I write it down. So I'm going to have minus m squared plus 4m minus 3. Even I can take minus 4 as common factor. It will look nicer. So I'll write minus 4, and then I need to change the signs inside, and I can see I'll need a little bit more space, so move this for 1 second, then I'll put it again. M squared minus 4m plus 3. I changed the signs, just it was more convenient for me to write it like this. And I still have the last entry to write down, so let me make space for that. I'm going to have m multiplied by 4m plus 1. That's the entry from the second row, plus 3 times, and then I need to multiply by the entry of the third row, minus 3m minus 4. So I'm going to get 4m squared plus m minus 9m minus 12, and this is 4m squared minus 8m minus 12. Again, I'm going to take common factor 4 and write m squared minus 2m minus 3. And that was the last entry I wanted to write over here. I'll write the matrix one last time. The entries for the first one don't change. I'm just gonna leave a bit more space for the longer expressions. Then for the second one, I'll write again the 0, negative 12, minus 4m plus 1, 4m plus 1. And then we have 2 zeros, so we achieved the row echelon form. I'm going to divide by 4 the third row, because the two last entries have 4 as common factor, so I can do that. And I'm also going to factorize the quadratic expressions that they have in the last 2 entries. So I'm going to have, for the one on the third column, I'm going to have minus, and then factorization will be m minus 3 multiplied by m minus 1. You can expand that to check that we get what we want. And on the other side, I'm going to have also m minus 3, but multiplied by m plus 1. And this is my row echelon form over here, and that was what we want to do for part A. Now we need a new video to discuss what's happening with the solutions depending on the different values of m.